Hello, and today we're going to be going over the Unit 3 review in MATLAB for MATLAB lessons 3.6 to 3.11. Using the graph, find the missing information. So using this graph, we have to find f of 4. Notice that 4 is in the parentheses, so this is our input or our x value. So we're trying to figure out what the y value is. So if you look at your graph, find the point that has an x coordinate of 4. 1, 2, 3, 4. So 1, 2, 3, 4. You've got an open circle here and a closed circle there. The open circle means that that point is not on the graph. The closed circle means it is on the graph. So the y coordinate for that point is -1. So f of 4 equals -1. That is your answer for part A. For part B, you're trying to figure out what x equals if y is 3. So you're trying to figure out what is the input if the output is 3. So look on your y-axis at 3. Again, we have a closed or open circle here, so that is not on the graph. If we go look at the other direction, this one is on the graph. So what is the x coordinate? Well, let's see. If we start from the center, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's to the left, so it's going to be -9. The third one, our input value or our x value is -7. So go over to -7. And then look for your y coordinate, which looks like it's a +1 because it goes up 1. So that's the y value. So these are, again, points. -7, 1. -9, 3. 4, -1. This last one, again, they're telling you the output value or the y value. You need to find the x value. So if y is -2, look for a point that has a y coordinate of -2. There it is. So that x coordinate is at 1, 2, 3, +3 to the right. So those are your answers for number 1. Number 2, you're asked to determine whether these tables represent functions or not. So what you're looking for are any x values that have more than one y value. So if you look at the first table, you've got 2 x values that have, or 2 of the same x value that have 2 different y values. So this one is not a function. So in the directions it just says write yes or no. So we're going to say no, it's not a function, but we have to justify our answer using pictures or words. I would prefer to use words, and again I would say there are 2 output values for 7. So there are 2 output values for 7, so it is not a function. If we look at the next table, all of our x values are different. Even though they all have the same y value, that doesn't matter. Each x value only has one y value. So that would be a yes, and again, because each x value has only one y value. And again, you could explain it a little differently than I am, but as long as it means the same thing. The next one, if you look at your x values, again, none of them repeat. So yes, each x value has exactly one y value. Alright, so that completes number 2. Going on to number 3. In number 3, you have to decide whether each point belongs to equation 1 or equation 2. Put an x in the appropriate box, and then one point belongs to both equations. So -2, -8. If I substitute this into my equation number 1, you can do that right in the box if you feel that you have enough room, or you can do it off to the side. but I'm going to do it right in the box. So if x is -2, I'm going to take -3 times -2 plus 6 and see if it equals, and it should, does it equal -8? So let's see, -3 times -2 is +6, plus 6 does not equal -8, so that would be a no. Now let's check it in equation 2. So if I put -2 in for x, I would have 5 times -2 minus 5 times -8. Does that equal 30? So 5 times -2 is -10. -5 times -8 is a +40. That does equal 30, so I'm going to put an x there. Maybe this isn't a good idea to put the work in there. So anyway, this is a solution to equation 2. So now I'm going to do the work off to the side. So equation 1, now I'm plugging in 3 and -3. So y is -3. So if I put -3 in the place of y, I'm going to do this over here. I'm going to rewrite the equation. Equation 1 is y equals -3x plus 6. Equation 2 is 5x minus 5y equals 30. So when I substitute 3 for, or -3 for y, my x value is +3. And then simplify, I would get -9 plus 6, which equals -3. So that does work. So this point here is a solution. So I'm going to put an x in that box. Now try it in equation 2. Again, the x coordinate was +3, the y coordinate was -3. 5 times 3 is 15. -5 times -3 is +15, which does equal 30. So that point is also it's also a solution for equation 2. So we're going to put an x in both of those boxes. Where this one was not, this one is. Alright, so now we're going to try the third one. Again, we're going to substitute y is 15 and my x is -3. So plug in 15 equals -3 times -3 plus 6. -3 times -3 is a +9 plus 6 does equal 15. So this is a solution. Now try it into the other equation. So if my x is -3 and my y is 15, I would have 5 times -3 minus 5 times 15. Does that equal 30? I'm guessing no, because this is going to be -15 and a -75, which is going to be even a bigger negative number, so there's no way that that's going to equal 30. So I am not going to put the x in that box. Alright, so now I'm going to try my next coordinate, -8, +30. So in equation 1, my y coordinate would go in for y, which is 30. My -3 gets multiplied by my x, which is -8, and then plus 6. So when I calculate that, the -3 times the -8 is a +24. Add your 6 and you get 30. So that does work. So that one is a solution. Now we're going to substitute in equation 2. So the -8 goes in place of x, the 30 goes in place of y. So 5 times -8 minus 5 times 30. Does that equal 30? And I'm guessing it's not going to, because this is a -40 and that's a -150, which will give us -190. So that does not equal 30. So do not put an x in that box. So we have one more to go. 10, 4. So again, put 10 in for x, 4 in for y. In my first equation, the y goes first, so 4 would have to equal -3 times 10, because that's my x coordinate, plus 6. So -30 plus 6 does not equal 4. So do not put the x there. If I try substituting it in my second equation, I put 10 in for x and 4 in for y. So 5 times 10 minus 5 times 4. Does that equal 30? Well, let's see. 5 times 10 is 50. 5 times 4 is 20. It's negative. 50 minus 20 does equal 30. So that one is a solution for that one. So you've got 3 solutions for equation 1 and 3 solutions for equation 2, and 1 point that was a solution for both. All right, moving on to the second page now. Number 4, you have a graph. This graph is representing the area. So A sub W is the area of the garden. So this is area. The horizontal axis represents the width of the garden. So they're saying that you're putting a fence around a rectangular garden that has a perimeter of 40 feet. So you have 40 feet of fencing to use. And depending on what your width is, the area is going to increase or decrease. So using our information in our table graph, when the width of the garden is 18 feet, what is the area? So your width is 18 feet. So if I look at my graph, my width of 18 feet is right here. So if I go up, that gives me that point about right here. What is the area? So go across, and my area is halfway between 30 and 40, so 35. Since it's area, it's got to be units squared, but what kind of units do we have? Well, it said the perimeter was 40 feet, so area is going to be feet squared. B, at what width will the garden have an area of 75 square feet? So they're telling you now the area. So we need to look at the y-axis, which is your area. And if we find 75, that's halfway between 70 and 80, and then go across, we see there's a point here, but there's also a point there. So there are 2 widths that would have an area of 75. So if we go down, what are those widths? Well, that's 5 because it's halfway between 4 and 6. And this one, if we go down, is 15. So there's going to be 2 answers, 5 feet and 15 feet. See, when the width of the rectangle is greater than 10 centimeters, what is happening to the area? Okay, so 10 centimeters, so they're saying the width is 10 centimeters. So here's our width of 10 centimeters. So what's happening to the graph as the width gets greater than 10 centimeters? So what's happening here? Well, if we look from left to right, it looks like it's decreasing. So it is decreasing after 10 centimeters. All right, so that's number 4. Number 5, you buy a phone from a provider that charges a flat fee of $20 per month. So even though it's per month and it sounds like a rate, the equation that you're going to be writing, I believe, is just for 1 month. So don't worry about the per month. We're only writing an equation for 1 month. In addition to the flat fee, they charge 3 cents for each text message. So the 3 cents for each text message, that is actually going to be your rate of change, which also is slope. It's going to be a linear equation. And the 20 is going to be your y-intercept. So in order to write a linear equation in slope-intercept form, now they're telling you to use C for the cost and T for the number of text messages. So instead of X and Y, you have to use C and T. So C, our cost, is going to equal the $20 plus the 3 cents. You can put 0.03 or just 0.03 for each text message. So we're going to multiply that 3 cents times T for our number of text messages. So don't get confused. Even though this is backwards, the number that's with your variable is your slope or your rate of change. The constant that does not have a variable, that is your y-intercept. So what does the slope represent for this situation? The slope which is 0.03, represents the cost per text message. Maybe I should have given a little more room for that. So the slope, which is 0.03, represents the cost per text message. Again, you can write your explanation a little differently as long as you've got your slope in there and you've got the explanation means the same thing as mine. The next question, what does the Y-intercept represent for the situation? So the Y-intercept, which is 20, represents the flat fee of $20 per month. Something to that effect would be correct. All right, so the next question, part D, how many text messages did you send if in a month you were charged $35? So if you were charged $35, you have to think about, well, does that 35 represent C or T? Well, what does C and T represent? C represents the cost, T represents the number of text messages. So 35 is definitely not a number of text messages. It is a cost. So in order to answer this question, we're going to have to substitute 35 for C in our equation and solve. So I'm going to try to do that over here, or I'm just going to put it in here. So there's not a whole lot of space for this. So your C is 35, and we want that to equal 20 plus 0.03 T. And then we're going to solve for T. So we're going to subtract 20 to both sides, which gives us 15 equals 0.03 T. Then we're going to have to divide 15 by 0.03. So we're going to have to do that with long division because we don't have a calculator. So I'm going to put 15 here, 0.03. Now, one thing with long division, if you have a decimal out here, you want to go over 2 places. So that means this decimal has to go over 2 places also. So we're going to have our decimal right there, and we're going to fill in those little loopies there with zeros. So now we have 3 and 1500. So 3 goes into 15 5 times, which gives us no remainders, but those zeros need to be part of our answer also. So it's going to actually be 500. So 500 text messages. That wasn't so bad. Okay, so there's the answer for number 5. Number 6, you borrowed money from your parents some time ago. Doesn't tell you how long ago, but some time ago. Each payment you pay back the same amount, and the remaining amount of money is calculated. So this is the amount that's left. You started this table on payment number 7. So even though there were 6 other weeks, you didn't start writing the table, keeping track until you got to week 7. And during that week, you had $240 left to keep record. So you had $240 left. So basically, you have points here. They're giving you a table, and they want to know how much money did you borrow. So you would have to go back to week 0 or week 1. Since you have 2 points, you're basically looking for the Y-intercept, because the Y-intercept would basically be your starting point. So at week 0, what did you borrow? And then every week, at week 1, you paid some money back. Week 2, you paid some money back. So you're looking for the Y-intercept. If they're asking how much you're paying each payment, that is going to represent your slope or your rate of change. So given a table, the easiest thing to figure out, first of all, would probably be your slope or your rate of change. So if we make this x1, y1, x2, y2, and substitute it into the slope formula, take your y2, which is 192, minus your y1, which is 240, over your x2, which is 8, minus your x1, which is 7. So you're going to get a negative slope, which makes sense because the balance, if you look at the balance, it is decreasing. But we need to figure out how much is it decreasing by. So when you have signs, so you got a positive and negative. So off to the side, I'm going to subtract the 240 minus 192. So I'm going to borrow. Okay, so 10 minus 2 is 8, 13 minus 9 is 4, so I'm going to get 48, negative 48 over 1, which is just going to be negative 48. Oh, so how much are you paying back each month? $48. So that would answer the question. You wouldn't want to put negative 48. That doesn't make sense, that you're paying back negative $48. You're paying back $48, which makes the amount left, your balance, going down. So now we want to figure out how much we borrow in the first place. So we're going to have to find our y-intercept. A couple ways you can do that. You can either plug it into point-slope form, or you could plug it into slope-intercept form. I like point-slope form, so I'm going to use that one. Y minus my y1 is 240 equals m, which is a negative 48. So don't forget, it's even though we put 48 here, the slope is actually negative 48. And then x minus my x1, which was 7. So if I distribute, I will have y minus 240 equals negative 48x plus, more math over here off to the side, 48 times 7, 56, carry the 5, 28 plus 5 is 32. So 326. To get the y by itself, I'm going to add 240. And now I'll have my equation in slope-intercept form, where my slope is negative 48, but my y-intercept, $566. So I borrowed $566. And I'm paying back $48 each payment. So in terms of slope and y-intercept, which do each of the previous answers represent? So we already kind of talked about that. So which one represents the slope? The $48. Which one represents the y-intercept? The 566. So when we write our equation in slope-intercept form, where y represents the amount left or our balance and x represents the payment number, we would have y equals negative 48x plus 566. And then the last question asks, how many total payments will you need to make to pay off the amount borrowed? So we want the y value, or the amount that's left, which is our y values, to be 0. So if we take our equation and put 0 in place of y, now we want to solve for x. Since my x term here is negative, I'm going to add 48x to the other side to make it positive. So I get 48x equals 566. Now I'm going to divide the 566 by the 48. So 48 goes into 56 once. Subtract, and I get 8. I did something wrong. I think I'm supposed to have 576 is what I originally planned. Okay, so here's where I need to go back and double check my calculations, because I thought I'm supposed to have 96 here so that I get a 12 there. So I'm going to go back here. Let's double check the 326, see if I did that correctly. So nope, I didn't. So 7 times 4 is 28, plus 5 would be 33. And if this is 33, my when I add that together, I'm going to get 576. So my y-intercept here is incorrect. I borrowed $576. And then my equation, so I have to change all those 6's to 7's. That's why we use pencil or erasable pen when we're doing math, because we make a lot of mistakes in mathematics. So now that that's a 7, we will get 96, which 48 goes into 96 twice. So you will need to pay it back 12 payments to pay the entire balance off. All right, so that's number 6. Moving on now to number 7. So given the equations below, state the form the equation is in. So the forms of your linear equation you have to know. They are slope-intercept. So that's one of them. The second is point-slope. And the third is standard. So those are the 3 forms of a linear equation. So if we look at this example A here, that is in slope-intercept form. And it's best used to find, well, what do you see from looking at the equation? The slope and the y-intercept. So the bank is down here, so they're saying that these answers here are going to come from this answer bank. So slope is one of the answers and y-intercept is the other, which is, you probably don't even need this bank down here, but it's there, and it will be provided on the test also. But what you are not going to be provided with is the different forms, so you have to know these names. All right, so if you look at the next one, the equation is in the point-slope form. Point-slope form, just like it says, it's best used to find a point. So if you look at this equation, the point is always the opposite of what's in the parentheses with the x. So your x coordinate comes from the parentheses with the x, but it's actually going to be a positive 1, not a negative 1. The y coordinate comes from the expression with the y, but instead of a positive 6, it's going to be the opposite, negative 6. So if you had to graph this line, you could graph the point 1, negative 6, and then use your slope to find the other points. So again, it's best used to find a point and the slope. Okay, so now let's look at C. C now is written in standard form. Hopefully you already knew that. And standard form is best used to find the x-intercept and the y-intercept. Because in order to find the x-intercept, you just have to take the constant divided by the coefficient of x. So your x-intercept would be 28 divided by negative 1, or negative 28. And then your y-intercept, you would just take the 28 divided by 4, which equals 7. So your y-intercept would be 7. So those, if negative 28 was on the graph, it'd be easy to graph, but negative 28 probably would not be on the graph, so you might want to rewrite this in slope-intercept form and then use your y-intercept and your slope to find more points. Okay, so that is number 7. Going on to number 8. Find the slope of the graph, the table, the graph, and the equation. And then they want us to state which one is the steepest. Now when you're talking about steepness, it doesn't matter if the slope is positive or negative. What you're looking for is the value, the absolute value of your slope being the largest. So the first thing we need to figure out is what is the slope for the table. So again, if we look at the first 2 points, you can use any 2 points, but I like to use the first 2 points because the numbers are usually smaller. So I'm going to call this x1, y1, x2, y2. So in my slope formula, y2 minus y1 6 minus 3 over x2 minus x1. Negative 4 minus a negative 2. Be careful when you're subtracting a negative because that's going to become positive. 6 minus 3 is 3, but the double negative here makes this negative 4 plus 2, which is going to be negative 2. So my slope is a negative 3 halves. Or you can change that to negative 1.5, but when we graph, usually we leave the slope in a fraction. Now let's find the slope for our graph. So you want to pick two good points. So this looks like a good point here, and really none of these look good until we get to the end. So same thing here, this one looks kind of good. So those actually look like they're evenly spaced apart, but let's see. From looking at the graph, from left to right, it's increasing, so we know our slope has to be positive. From one point to the other, if we count the rise over the run, it's going up 1, 2, 3, and over 1, 2, 3, 4. Is the same thing happening here? Up 1, 2, 3, 1, 2, 3, 4. So I'm pretty confident that my slope is a positive 3/4. The last equation here, they gave you the equation in slope-intercept form. You just need to know which number is the slope. Well, the slope is your coefficient in front of x. If there's no number there, then it's equal to negative 1. So all of our slopes, oh no, two of our slopes are negative, one of them is positive. So slope equals negative 1. So we've got all of our slopes. Now we have to answer the question, which one is the steepest? So disregard the negative sign. Is 3/2, 3/4, or 1 bigger? Which one of those numbers is bigger if we disregard the negative? And hopefully you came up with 3/2 because that's 1.5, where this is 0.75 and that's 1. So the 3/2 or negative 3/2 is the steepest slope. Very good. On to number 9. So in number 9, we have to explain how to determine whether the rate of change is increasing, decreasing, or constant. So it's increasing if there are a couple ways you can tell. It depends on if you're given a graph or if you're given an equation. So it's increasing. I'm going to probably use more than just this one line, so I'm going to make a second line here for my answer. Okay, so it's increasing if the slope is positive or the graph is going up from left to right. So that's increasing. It's decreasing if the slope is negative or the graph is going down from left to right. And I guess I should have made more lines here. The slope is constant if the slope is 0. I guess I could have started that out with just constant if the slope is 0, or the graph is a horizontal line. All right, so there's a lot of information there. Hopefully you found some space. I mean, all of this space over here, we're probably not going to use a whole lot of it. Well, maybe we will, because we have to substitute these values in for x here, so that we might need that space. So you could have written you could use the space above here. We have a lot of space up here that you could include in that description. But again, it's increasing if the slope is positive or the graph of the line is going up from left to right. decreasing if the slope is negative or the graph is going down from left to right, and the slope is constant if the slope is 0 or the graph is a horizontal line. All right, number 10, you're given an equation here, and you're evaluating the function for the following values, and then you're supposed to write it as an ordered pair. So we're finding f of -4, which means that our x coordinate is going to be -4. So if I do that off to the side, f of -4 is going to equal -7. Here, I'll zoom in a little bit. And then my x, again, I'm plugging in -4x, and then +1 -6. And then it's just a matter of simplifying. -4 plus 1 is -3, times -7 will be 21. So it'll be a positive 21 minus 6, which will equal 15. Okay, so we substituted -4 for x, we added, we got -3, multiplied, we get 21, minus 6 is 15. So as an ordered pair, it's going to be -4, positive 15. And over here, f of -4 equals 15. So we can write it in function notation or write it as an ordered pair, or both if they ask you to do both. Okay, I'm going to switch out my colors for the next one. We're going to substitute 0 now for x. So f of 0 then is going to equal, this is supposed to be brown, but you can't hardly tell the difference, -7 times 0 plus 1 minus 6. So again, we're substituting 0 for x. 0 plus 1 is 1. -7 times 1 is -7. Minus 6 is going to equal -13. So that is our output value. F of 0 then equals -13. As an ordered pair, it would be 0, -13. So again, going back over here, you substituted 0, added 1 and got 1, multiplied by -7, which gives you -7, minus 6, which gives you -13. And last but not least, we need to now substitute 1 for x. So we know x coordinate is going to be 1. We just need to find the y coordinate. So again, we're substituting it into the same equation. There's a -7 out front, and then your x is being replaced with 1. There's a +1 in the equation and a -6. So when we simplify, 1 plus 1 will equal 2, times -7 will be -14, minus 6 will equal -20. So our output value, needs to adjust a little bit. Our output value is going to be -20. So the point is going to be 1, -20. Okay, so got a little bit of a glare, but hopefully you are able to see it now. So that is your substitution. All right, and that's number 10. Next page. Number 11. You are selling buttered popcorn and you are selling caramel corn to raise money for the Spanish Club. It costs $3 for each bag of buttered popcorn. Zoom out so you can see the whole thing. And $5 for each bag of caramel corn. Your goal is to sell at least $45 worth. So your inequality, if we look at the graph here, you can see the buttered popcorn is on the x-axis. So we're going to say the buttered popcorn is x, the caramel corn is on the y-axis, so the caramel corn is going to be our y. The cost for the buttered popcorn was $3, so in my inequality I'm going to say 3x, so 3 times the number of bags of buttered popcorn, plus 5y, because it was $5 for each bag of caramel corn. Since we want to sell at least $45, we want to say greater than or equal to 45. And this is, again, a great one to graph using our x-intercept and y-intercept because it's in standard form, and because both the 3 and the 5 can be divided evenly into 45. So my x-intercept, if I take 45 divided by 3, it gives me 15. So 15, 0 is my x-intercept. My y-intercept, if I take the 45 divided by 5, that gives me 9. So my y-intercept is the point 0.09. So that's the easiest points to get. So 15 is our x-intercept. Okay, I was concerned that we weren't going to be able to get 15 on there, but it is on there. So 15 is my x-intercept, 9 is my y-intercept. Since our equation is greater than or equal to, it's going to be a solid line. And if we were to solve this equation for y and subtract the 3x and divide by 5, let's do that. If I subtract 3x, I would have 5y is greater than or equal to negative 3x plus 45. If I divided by 5, I would get y is greater than or equal to negative 3/5 x plus 9. So when we solved for y, the sign did not flip. So that greater than sign does mean we would shade above. And if you want to test a point, say example, we test 0, 0. So if we substitute 0 for x and 0 for y, we would get 0 is greater than or equal to 45. That is not true. So 0, 0 should not be in the shaded area, and it is not. So we know we shaded correctly. Okay, so that is number 11. Number 12. Again, we are graphing our linear inequalities. The first one here is in slope-intercept form. So our y-intercept is the point 0, negative 5. It's on the y-axis. And our slope is a positive 3/4. So if it's positive, it's going to go up to the right. So we want to count up 3 spaces, then to the right 4. Starting at our y-intercept. So count 1, 2, 3 up, 1, 2, 3, 4 right. Now on the computer, if you have to graph this, you would just use 2 points. But if I want to get a better graph on paper, I want to do this again. 1, 1, 2, 3, 4. So I went up 3 over 4. You can also go the opposite direction and go down 3 and to the left 4. Now before you draw your line, make sure it's equal to, which it is, so it's a solid line. And then because the y is on the left, we can use the less than sign, which means we can shade below. And then if we test the point 0, 0, if I put 0 in for y and 0 in for x, I would get the statement 0 is less than or equal to 0 times 3/4 is just 0, minus 5 would be negative 5. Is 0 less than negative 5? No, it is not. That is false. So 0, 0 should not be in the shaded area, and it's not. So I tested the point 0, 0. You could test really any point, so if you wanted to test a point that was in the shaded area, that's fine, but then it should be true. Okay, number 12b. This one is in standard form, but if you try to divide the negative 4 by the negative 3, you're going to get a fraction or a decimal. So I'm actually not going to use the x and y-intercept. I'm going to actually solve this equation for y. So I'm going to rewrite it over here. Make sure that you copy it down correctly, and notice there's no line underneath. So then add 3x to both sides to get negative y is less than, put the 3x first and then the minus 4. And be careful, we're dividing by a negative number. We have to divide by negative 1. And when you divide all the terms. When you divide by a negative number, that inequality sign is going to have to flip from less than to greater than. So our final inequality will say y is greater than 3 divided by negative 1 is negative 3x, negative 4 divided by negative 1 is a positive 4. So that is our equation in slope-intercept form. Our slope is negative 3 over 1, which means we're going to go down 3 and then to the right 1. Our y-intercept is the point 0, 4. So I'm going to graph the point 0, 1, 2, 3, 4 right there, and then I'm going to count from that point down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, 1, 2, 3, 1, or I can go up 1, 2, 3, 1. Because there's no line underneath, it's going to be a dashed or a dotted line. And then because it's greater than, it's going to be shaded above. If I test the point 0, 0, if I plug, I can use the original equation. If I put 0 in for x and y, I'm basically just have 0 on the left is less than -4. 0 is not less than -4, that's false, which means 0, 0 should not be shaded, and it is not. So we tested the point 0, 0, and we got something that was false. All right, I'm going to go ahead and stop right here, and then I'm going to start up this another spot. Okay, so here's the rest of our review. You're given a graph. The graph came out pretty dark, but it's supposed to be a dashed or dotted line here. You can kind of see the little dots, but that is supposed to be a dashed line, and this is the part that's shaded. Basically what you're asked to do is you're deciding whether these points are part of the solution set or are not. So if they are part of the solution set, they would be in the shaded area, but not on the dotted line. Anything that's on the dotted line is not a solution. So example, for the first point, 0, -2, that's on the dotted line, so that is not a solution. So that would be a no. The point 5, 4, if we go to the right, 1, 2, 3, 4, 5, and up 4, that's not in the shaded area, so that also is going to be a no. The point 6, 0, 1, 2, 3, 4, 5, 6, that is in the shaded area, so that one would be yes, that is part of the solution set. The next point, -1, -2, is just outside of the solution set, so that would be a no. And then the last one, -5, -7, go to the left, 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6, 7, is going to be down here, so that is another yes. So we've got 3 no's and 2 yeses. Moving on to number 14. So in number 14, you have a table here. This, they've got little t, and then they got a capital T. The little t is representing time, and the capital T is representing temperature. So these are degrees, temperature in degrees Celsius over a 24-hour period. And they're saying that T hours after midnight. So 0 is midnight. So 2 would be 2 a.m., 4 would be 4 a.m., 6 all the way up to 12 noon, which is 12 p.m. So then at 14, that would be 2 p.m., and 16 would be 4 p.m., and 18 would be 6 p.m., and so on. So let's see what they're asking. What was the temperature at 4 a.m.? So here's your time at 4 a.m. So now we need to look at the graph. Here is our time at 4 a.m., and our temperature is -3 degrees. And again, that was Celsius, so -3 degrees Celsius. The second temperature, what was the second question, what was the temperature at 8 p.m.? So if this is noon, 2, 4, 6, 8 p.m. is right here at 20. So the temperature was 0 degrees Celsius. The next one, at about what time or times was the temperature at 2 degrees Celsius? So now we're looking at the y-axis. We're looking at +2 here. And if we go across, there are 2 different times at which it is 2 degrees Celsius. So we have to look really closely at our graph. If we zoom in, it looks like it's about halfway between this line and this vertical line. So that's going to be about halfway between 11 and 12. So I'm going to say 11:30 a.m. That's one of the times. The second time, again, it looks like it's halfway between 2 vertical lines. So it's about halfway between 16 and 17. So if this is 4 o'clock p.m., then halfway between 4 and 5 would be 4:30 p.m. So both of those would be answers. So both of them had a temperature of 2 degrees Celsius. All right, so now we have the last problem on our review, and it's going to involve slope and y-intercept and writing an equation. So you join a volleyball league. There is an initial cost. So the initial cost is going to be your y-intercept to join, plus a fee per game. So that sounds like a rate. Well, that's your rate of change or your slope. Now they give us some information. They tell us the cost for 4 games is $53 and the cost for 9 games is $88. So the two things we're comparing is the number of games and the total cost. So the number of games is basically your X value. The total cost is basically your Y value. So if they tell us 4 games cost $53, that is a point. So it's the point for 53. The second point that they're giving you is the 9 games costing $88. So 9 is the number of games, 88 is the total cost. So now what can we do with 2 points? We can find the slope. So if I label this x1, y1, x2, y2, and then use my slope formula, which is y2 minus y1 over x2 minus x1, I'm going to subtract 88 minus 53 over 9 minus 4. So the 88 minus 53, I'll do off to the side. I'll get 5 and 3, 35. And then 9 minus 4 is 5, which equals 7 when we divide. So our slope or our rate of change is 7. So what part of this problem is representing the slope? Well, the slope is our fee per game. So if they ask what is the cost for each game, that's again our $7. So that would be our slope. What is the initial cost to join the league? So we haven't figured that out yet, but the initial cost to join the league is going to be our y-intercept. Well, we have the slope and we've got a couple of points, so how can we find our y-intercept? Well, you can use point slope form or slope intercept form, whichever you'd like. I like point slope form, so I'm going to use y minus y1 equals m parentheses x minus x1. The y is part of the formula, minus my y1, which is 53, equals m, which is my slope, x minus my x1, which is 4, and then I'm going to distribute 7x minus 28, bring the left side down, and then add my 53. So I get y equals 7x, and then I have to take 53 minus the 28. I have to borrow, and that will give me 5 and 2, or 25. So here's my equation. Y equals 7x plus 25, so my y-intercept, or my initial cost in this case, is $25. In step 3, they want us to write the linear equation in slope-intercept form. Well, we've already got that. However, it says the total cost C. So they're telling us to use C to represent the total cost and G to represent the games. So earlier we said the total cost was Y and the number of games was X. So just replace your Y with C and your X with G. So it's going to be C equals, instead of Y equals, 7G plus 25. So there's our equation in slope-intercept form. Now they want us to know, they want us to use the equation to find the cost for only 2 games. So then 2 is basically going to be our G. So C is going to equal 7 times 2 plus 25. So 7 times 2 is 14, plus 25 is going to be $39. So to play 2 games, it's $39. And that is the end of your review for your test. Good luck.